Hello everyone. Today we'll be going through IGCSE physics and the topic is understanding speed. Main topic is describing motion. This topic will be covering according to the syllabuses of Cambridge, Edexcel, EQA and Oxford. Keep in mind this describing motion chapter is covered in these four videos which are available in the playlist. You can check that as well. Now express trains slow buses. So like we are having in daily life, we are having a lot of things which are moving and motion we are experiencing in daily life. How we can understand speed, this helps us describe how objects move in the real world and forms the foundation of many IGCSE physics concepts. So there's a detailed topic of IGCSE which is related to the motion. You will have to go through this topic in detail. Mastering the idea of speed, how we can understand the speed better. Speed is telling us how fast something is moving or how slow something is moving. It links distance with time. So distance covered in specific time. So speed is a scalar quantity. You will have to keep in mind it's not a directional quantity, it's just a scalar quantity. We use it to describe motion. Faster speed means more distance in less interval of time. Like for example, this one 30 kilometer per hour. So if it is without direction, then it will be 30 kilometers will be the distance covered in 1 hour. So that is the distance covered in time. So speed is a measure of how quickly an object covers a distance, and it helps us to compare different types of motion in a simple and clear way. We can compare the car motion with the rocket motion and those type of things. How we can calculate the speed? The formula of speed we can discuss, that is in form of triangle. Speed is equal to distance divided by time, and we can have a triangle of variables also. So distance, speed and time. Speed is equal to distance divided by time. Similarly, we can say that the distance is equal to speed into time, and time is equal to distance over speed. So speed is distance divided by time, distance measured in meters, and these are the standard units, and the time is measured in seconds. So unit is meters per second. These are the standard units, but we can measure it into like kilometers per hour or kilometers per second in case of fast moving objects, or we can measure in centimeter per second in case of like slow moving insect or like that. So formula triangle helps rearrange. So we need to rearrange the formula to calculate the different variables which are unknown. The speed formula shows that speed depends on both distance and time. Once you know two values, you can easily find the third one. So in formula, it's having three variables. So out of three, if two are given, third one you can find easily. Now, average speed versus instant speed or instantaneous speed. So average speed is what? Total distance covered in total time. The whole journey we are checking how much is the speed for the whole journey. And instant speed means the speed at that particular instant. So it's a single moment speeds. Vehicles change speed often. So the speedometer of the car is giving us the instantaneous speed. Average smooths these changes, and the speedometer shows instant speeds mentioned here also. The speed at one instant is known as instantaneous speed at that this particular moment, right? And the whole journey from this place to this place is like 1 minute journey, and this will be over a period of time, which is average speed, which we are checking the total distance covered with the total time. Average speed tells us how fast an object moved overall. while instantaneous speed tells us the speed at one exact moment. Both ideas help us understand real life motion more accurately. Similarly, we can understand things from the graphs also. So, reading speed time graphs, this side speed time graphs and distance time graphs also. So, here we have given the distance time graph. So, distance time graph is like this one, distance on y axis and time always we are taking on x axis being independent variable. So, if the graph is like this one, fast, steady speed. So, this graph, green color graph, is fast and steady speed because its gradient is more and higher than the other. So, this portion of the graph shows the steady speed, and then this is no change. So, it's stop. It's representing the stop that the body is in at rest, and then steady speed return to start position. So this is like returning to the start position, and we can show the graph also, like for example this one is accelerating and this is decelerating, slowing down, and then this is the stoppage. So this is how we can understand the things on the graph also. So graph shows how speed changes. Flat line means constant speed. So flat line will be constant speed, and upward slope will means acceleration. Downward slope means slowing, and area under the graph gives us distance. A speed time graph lets us see changes in speed quickly and clearly. By looking at slopes and areas, we can tell whether something is speeding up, slowing down, or moving steadily. So, from the graphs, we can understand better the different situations of a moving object. Then, slowing speed problems. For slowing speed problems, where brakes are applied or like that one. So, we need to be careful while solving these problems. We'll have to check units first. Units will be similar units in the formula. We'll have to use standard units and choose the correct formula also, and rearrange whenever required. You will have to rearrange the formula, show all steps clearly, and check if answer is sensible. So we have solved a sample question here. So calculate the average speed of a car that covers 500 meters in 20 seconds. So formula chosen is average speed is equal to distance over time. So average speed distance is 500 meters, 500 divided by 20 seconds, which is 25 meter per second, or it's roughly 80 miles per hour. Speed calculations become easy when you work step by step and use the right units. Clear working helps you avoid mistakes and understand the method better. So you will have to use the units always, similar units, standard units, and if for example speed and time is given, for example, and speed is in meter per second. So your distance, for example, time is also given. So time should also be in seconds. If time is in minutes or hours and speed given is in meter per second, then you will have to use uniform units. You will have to change the units to meter per second or so accordingly that one you will be able to use. So again, describing motion is in 4 videos which are available in the playlist. You will have to go through all these to cover the complete topic. Thank you very much for watching. Take care. Bye.